Welcome to my tutorial on meshing with Gmsh. We'll see here how to create a two-dimensional mesh in Gmsh and how to refine the resulting mesh, and then we'll learn how to export it to a form which can be used for a Code-Aster or Salome-Meca study. So Gmsh is a open source meshing software. It's lightweight compared to Salome mesh module, and it can do both 2D and 3D meshing. Now let us proceed. So this will be our outline of presentation. We'll first prepare the geometry file in Gmsh. It's called Geo file. Then we'll create a 2D mesh out of that Geo file, and then we'll refine the mesh and we'll export it to a made file which can be read by Salome-Meca or Code-Aster. And then we'll need to create the node groups in Salome-Meca. This is because when we create the groups in Gmsh, when we export it into a made format, the nodes are also exported as zero-dimensional elements. So therefore we need to play a little trick to convert them into node groups, and then of course we can finally save the mesh along with the node groups as a made file. So let us move ahead. So let us first see the slope geometry and the material properties. There is a rough sketch of the slope geometry. It has been taken from Smith, Griffiths and Marget's book, Programming the Finite Element Method. So we have a 2:1 slope. This portion is 20 meter long, this slope portion is 20 meter long, and the remaining part is also 20 meter. That is what is the slope analyzed by in this book. And the height of the slope is 10 meter, and we are also modeling the soil below the horizontal surface up to a depth of 5 meter. And these are my names of the groups that will be used in the mesh file. So this is called horizontal support or edge support. This will be my left support, this will be my right support. Then this is top line. This is necessary so that we can later on add some surcharge load on it and see the effect on the slope stability. Then this I'm calling it slope line, and this as toe line. And the material properties used in this reference for this slope are this gamma is 20 kilonewton per meter cube, the bulk density of the soil. Then internal angle of shearing resistance phi is 20 degree and cohesion is 15 kilopascal. And we are naming this bottom layer as the base layer and the slope material as top layer. In their problem, both top and base layer has the same material properties, but we may later on decide to analyze the whole slope with different materials at top layer and base layers. That's why we are naming them into different groups. So let us start with Gmsh now. So let us launch Gmsh. So Gmsh. Now we'll create a geometry. When we open the Gmsh, it will create a blank file called untitled.geo, and we can modify this file and save in a different name, and of course that can be changed in this can be changed in settings of the Gmsh also. So now we need to create the elementary entities like points, lines and surfaces. So we'll go to geometry module. It has 3 modules: geometry, mesh and solver. I think many of you are already familiar with Gmsh. So going to geometry module, these are my elementary entities. So we'll add the point and then lines accordingly. So for that we'll again refer to the slope geometry. We'll take up the origin here and we'll do everything in XY plane so that plane strain analysis can be done in Salome-Meca. So we'll have the points 0, 0, 0 here, then 60, 0, 0 here, and so on. So let us list the points first. So in the slope geometry, the points will be, this is my origin, therefore let us write down the coordinates at the points. So this is my 0, 0, 0, then this will be my 60, 0, 0, then this is my 65 and 0, then this point is my 45 and 0, then I have this as 20, 15, 0, then I have 0, 15, 0, and this point is 0, 5, 0, right? So 0, 5, 0. So these are my points that are to be entered in the Gmsh for creating the geometry. So let us go back to our Gmsh now. So I'll add the point first. So this is already 0, 0, 0, and in Gmsh now a point is defined by its coordinates as well as something called a characteristic length, which governs the mesh size around that point. By default it starts at 1. Now let us first do it as 0.5 and then add the point. Now you see when I am moving this, the location has changed, so while adding the point I should not come out of this, or what we can do is we can press the shift key and then even while coming out nothing will change there. Okay, so this we should remember. So first point we add as 0, 0, 0 and then hold the shift key and then press add. Then next point is my 60, 0, 0. So 60, 0, 0, again hold the shift key and then add. Then our next point is 65, 0. So 65, then hold the shift key and add. and then we have 40, 50, so 40 and 5 and 0. Then we'll have 20, 15 and 0, so 20, then 15 and 0, 20, 15 and 0, and then 0, 15, 0, so 0, 15, 0, then add, and then we have 0, 5, 0 another point, so 0, 5, 0, and we have added the required points. Now we can either close the screen from here, or we can press Q in the keyboard to come out of that menu. Now we are going to add line, so we'll click line here. Then I need to select the start point and then select the end point. So the line has been generated. Similarly, I'll go on adding the lines. Sorry, I should have selected this point and this point, then this point and this point again, and then this point and this point, and then this point and this point, and finally this point and this point. So my outline of the slope is generated now. So next I will need a line to separate the top layer from the base layer. So for that purpose we will again add line. So this will be my first point and this is my end point. So I have got them as the points. Now I can press Q and come out of that menu so that I don't accidentally add any point or line. So now what I can do is I can reload the script and see the script now. So this will be saved in my working directory as untitled.go. So I think it will be in my home directory. So let us go. Let us see if it is. Yes, this is my untitled.0. So now geo I can rename the file. So I will call it slope01.geo and rename it, and now I can open it in my text editor, and we have seen that these are the descriptions of various points and these are the descriptions of various lines. Okay, so now I can close this to open again another Gmsh. So I'll call Gmsh slope01.0. I think it will open the file in Gmsh. Yes. Now I have renamed the file and reopened it in Gmsh. Now I will again go to the geometry module and then in order to generate the groups I will have to create some physical groups here in this file. So for that I go to the physical groups menu, then add, then in the physical group menu this new version of Gmsh gives us point, curve, surface and volume. So line is also a curve here, so I will select curve and I will select the various lines for different groupings. So I have selected this, then I have selected this also, then I will press E to end selection, and then I will name it, say left support, left support. Okay, then I can either close it or I can once again add another curve in the same menu. So now I will go to add right support, and select this line. So press E to end the selection. Now I define a new group, that is H support, and I select this line. So again press E to end the selection. Then I need to name this as toe line, so I'll call it toe line, T-O-E, toe line, and then press E, toe line, and press E, and then I have slope line, and then I'll select this and then press E, and then I'll select toe line. So toe line, and this is my line here. So press E and then Q to abort. So now if I reload the script, and then I will have to reload here. Now I have seen that these physical curves have been named now. Now there is another good way to refine my mesh if needed. For that purpose, what I can do is I can define some parameters, like say mesh refining parameters, then I'll call CL equal to 0.5. In Gmsh, every statement must be completed by a semicolon, that we must not forget. Then I will call say CL1 as say 0.25. okay, and then what I can do is I can remove this 0.5 by CL, so that later on for refining I can change simply the value of CL, etc. Okay, so this is a better option. I didn't do it initially just to show that why it is needed and how it can be done, but you can start defining these parameters at the very beginning, and then using this CL as the parameter for points. So I can save it, and then going to Gmsh I can reload the script. Okay, then what I need to do is I need to define the two-dimensional surfaces so that we can mesh it. So first I'll have to add the elementary entities. So add plane surface. So for creating plane surface, we need to select the surface boundary, and we can press Q in keyboard to abort the process. So first we'll create the base layer. So let us select the surface boundary, Now you can see that since I had generated this in a clockwise manner, counterclockwise manner, serially, so therefore by selecting 1 it has selected the whole loop. And then I need to select this line also, so I'll select this again, then press E to end the selection. So now this surface has generated, and you can see that there is these two dotted lines showing the surface. Okay, so it's a surface. And similarly I can add another surface, so plane surface. Now I'll select these boundaries. So this was again serially made, so that whole thing is selected. Now this is another boundary, so this will make my top layer, so I'll press E, and then this new surface has generated. Alright. And then I should also give some name to these surfaces, and if you want to see the IDs of these various lines or planes or points, what we can do is we can go to tools and then options, then we can save, we can go to, not here, I'm sorry, I should go to tools and visibility. No, not even here. I should go to tools and options, yes. Geometry, yes. In the geometry tab I get visibility. So if I want to know the labels, I would put point label, so you can see the point labels, then the curve labels, so it gives us the line number, geometrical identity as well as physical identity. Okay. Then also we can see the surface labels, which are plane 1 and plane 2, but usually we may not make all of them visible just to avoid cluttering. Okay, so let us just put the surface labels, and then we will again go to physical group, so physical groups, add. Now I'll add the surface labels to it. So first I'll make the base layer, and select the surface, so I'll select this plane and done, so E, and then I'll go for top layer, naming the top layer, and then select this plane and then put E and come out of that by pressing Q. So now I will reload the script, and if I again see the script, I'll have to reload it here itself, reload script. It has not come, I do not know why. Cancel. I'll say edit script, and then I'll say reload script. Yes, now it has come, reload. Now you see the plane surfaces has been generated using the curve loop, and then they have been named as base layer and top layer. So here you can see that we can write everything even in the script without starting the GUI, and for that one thing we need to remember is Gmsh uses the name of the entities, say point, line, curve, etc. And for physical group we use physical curve or physical surface, like that. If I want to name the physical line, then it will be physical curve here. Then the ID of that is put inside a parenthesis and then the equal sign, and in the curly brace we need to put the parameters that define that geometrical identity. Like the line 1 was started from point 1 to 2, so this is my list of identities. Okay, so that way we can do the whole thing even in the text mode itself. Okay, now let us go to the mesh module and let us see how the mesh looks like. So for let us go to mesh module and let us press 2D, and we have seen that this is my mesh. Okay, this is quite okay, but what happens in some situations I may need, suppose this is a slope stability analysis problem, so I may like to have a more finer mesh in this region, and maybe in this region too, and maybe within the interface line I may want to have a more finer mesh around this interface line, so that if the property is changed in the model, then I can pick up what happens in the interface in a more better way. So for that what we can do is, we can, if I want a finer mesh as a whole, I can just change this characteristic length of all these points, make them a smaller value, and I will get a finer mesh. Okay, or even I can go for refine by splitting. If I press it, it will be a too fine mesh. Let me show you. So this has become a very fine mesh. I may not need so much a fine mesh in my actual analysis, so I can get rid of this by just reloading the script in the geometry module again. So if I reload the script again, the mesh has vanished. Alright, so now again I will go to the mesh module, and then I will create the 2D mesh, and now I want to locally define the mesh, and for that what I will do is I will add some dummy entities, like I can have points here and there in the region where I need the more fine mesh, and then I can edit my script to do that. Okay, so let us add few more points in this region, in the slope region here and there, and also here, and then we will refine our mesh later on. So for that, let me go to elementary entities and add point here and there. Now I will just randomly add a few points here and there, here and there. So press E, then I'll press here, then press here. You see that the labels are shown already. Then I may need here, then maybe here, then maybe here. Okay, so these are some of the points I have added. Now I will escape from this menu and I will reload the script again. So reload the script. Now you can see that new points have been added from point 8 to point 17, and I should have added the characteristic length there itself in the menu itself. That can be done. Say if I add one more point, say point, then here I could have written say CL1, and then I could have added another point, maybe somewhere maybe here. So then if I reload the script and then go to reload, then this new point has the quantity CL1 here. So now since I didn't do it earlier, so I'll have to manually do it here. CL1, then CL1, CL1, then CL1, and then CL1, and so on. CL1, 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 and then CL1. So let me save it, then let me reload the script again. Now if I mesh, then let us see what happens. Now you can see that nothing has happened. There is no node on these points. Why that has happened is that although I have added the points are not yet part of the plane. So to add these new points to the part of the planes, what I can do is I can edit this, and now I'll write a line, say point, then I'll list the points which I should add. So let us see here from point 8 to 14, they belong to plane 2, and points 18 to points 17, 15 to 18 belongs to plane 1. So in the script file, what I will do is from point 18 to 14, from point 8 to 14, I'll add to physical surface, plane surface 1. Is it plane surface 1? No, plane 2. So I'll write the expression. So 8, 9, 10, 11, then 12, then 13, then 14. Let me verify. Yes, it is up to 14. Then I will say in, then surface 2. So point, then the expression list, then in surface, then the expression list of the surface. Okay. We should be sure that this is my plane 2. Yes, that's why I should add 2 here, then a semicolon. Then similarly point, we have 15 to 18, so 15, 16, 17, 18, then in surface 1. So let me save it, then let me reload the script again, reload the script, then remesh it, Now you can see that around these points my mesh is finer now. Okay, and I can change that fineness by changing that characteristic length. Alright, now what is happening, the mesh is finer around these points only, nothing is happening around these points. So what I will do is I will change the characteristic length of these points now, 0.5, 0.4, and then also 0.3, 4 and 5. I will change the characteristic length. So again I will go to this, so 3, 4 and 5, so 0.3 I will make it CL1, 3, 4 and 5, CL1. So let us see what happens then. Let us save it, let us reload the script again, reload the script and then again mesh it. So now you see this whole zone is finer now compared to this zone, and also here this whole zone is finer now compared to this zone. You can see that the whole thing is fine now. Okay. Now if I want fine mesh here also, then I will have to change the characteristic length of 0.7 also. So let me do it. So 0.7, I will make it CL1 and save it, then reload the script and then mesh it again. So I'm getting fine mesh in this zone. Okay, now if you don't want that fine, then you can reduce the value of CL1, that's all. So CL1 was 0.25. If I make it around 0.3, I think that will be okay. So by trial and error you can decide how you can decide finally what should be your final mesh fineness. So now this is slightly less finer. Okay, and I think this is okay. I hope this is a good mesh for analysis purpose. So now I will save the mesh. If I click here save mesh, it will save only in the native format of Gmsh. The extension is .msh. So it will save in my working directory. It will save a file called slope1.msh, and let me see that. So slope1.msh is here, and this again can be opened in text editor. So it gives us the nodal coordinates, element connectivity and other physical identities, etc. in an ASCII file. Okay. Now, but I don't want this kind of file, so what I will do is I will export this file to MADE format. So for that I go to export menu and then I'll save it in appropriate file. So I will put it here as say Salome-Meca.made. Okay, it will guess from the extension itself, or you can select here the type of file. It is made is there, so press OK, and then this is my made option. I should keep this unchecked, okay, in order to save the physical groups. So let us press OK. So now I will have in my directory this made file as well. So let us see. I have this made file. Okay. So this completes our meshing part in Gmsh and exporting it to the made file, and then we will see how to create the group of nodes in that made file. So this we will see in the other part of the tutorial.